So we are on page 9 in your workbook. We're going to be talking about 1, 2, transformations of functions, and we are going to be looking at graphs and how you can change those graphs. So first of all, on page 9, we've got the graph of f of x, and this is the graph that says f of x equals the absolute value of x. Now, this is actually a type of a parent function. And a parent function is the most basic type of function. So we have several different parent functions. So for example, y equals the absolute value of x is the parent function for the absolute value family. So any function that has an absolute value and an x, only raised to the first power, is going to have this shape. Another parent function is the parent linear function, y equals x. The parent quadratic function is y equals x squared. And I'm trying to think, there is one more that you'll probably see is the parent square root function. And that is y equals the square root of x. So I'm going to pull Desmos out. I'm going to graph those so we can look at all the parent functions. So y equals x. Let's square everything away here. Fix my settings. Okay, y equals x is my parent linear function. So anything that has an x to the first power and no other x's in it, the graph of that is always going to be a line. And we already talked about the absolute value of x. And if I don't want those to appear on the same graph, I'll just unclick that one. So that's the absolute value function, parent function. And then we also have y equals x squared, which is the parent quadratic function. So anything that has an x squared in the equation and no other exponent that is higher than a 2, the graph of that quadratic function is going to be a parabola. And then our last parent function you'll see is the square root function. So y equals the square root of x. Oops. We'll have this shape. Okay, so those are our parent functions. Now what we're going to do today is we're going to move these guys around and see what happens. So then part A tells us to take the graph of the function absolute value of x and add different values for each value of c. Okay, so I'm going to go a little bit further and we're going to start taking notes about the transformations of parent functions. So f of x is just going to be general notation for any type of function. And in this case, f of x is going to stand for any of our parent functions like what we had graphed over here, okay? So the first transformation we're going to look at is what happens if I add a number or subtract a number inside of grouping symbols. Now, grouping symbols could be absolute value bars. It could be a radical. Now with x, I'm going to insert grouping symbols around the x. I'm going to insert parentheses. And I'm going to insert parentheses around the x, but before the square. So I've got all my grouping symbols here. Okay, so I want to see what happens if I add or subtract a number inside of the grouping symbol. And actually, let's just see what happens if I add a number inside the grouping symbol. Okay, so if I add a number, let's see, plus, whoops, inside. So let's say I do plus 3. Okay, so without the plus 3, if you notice this point was at 0, 0. And then when I do plus 3 here, well, it went backwards 3. Okay, I wonder if that's going to happen to our parabola. So originally the parabola has a vertex at 0, 0. If I add 3 inside the grouping symbol, oh, it also went backwards 3, or actually to the left. Let's see what happens with the absolute value function. Let me get rid of these guys. Here's the parent absolute value function. If I add 3 inside the grouping symbol, it also goes backwards or to the left 3. Now here's the parent linear function. This one was is going to be a little difficult to see, but I want to point out this point right here. If I add 3 inside the parentheses, it also shifts to the left 3. So what we'll add to our notes is that anytime you add a number inside the grouping symbol, that is going to be a transformation to the left H units, whatever that number is. So if it were a 2 here, you go to the left 2. 3 here, you go to the left 2. Okay, and I'll put an arrow there. Okay, now if I subtract a number inside the grouping symbol, let's see what happens. Okay, so instead of adding 3, now remember all of these ended up at that negative 3. So if I change all these to, hold on, let's not graph that one. Let's start back with the square root. I'm going to get rid of that plus 3, which remember it moved that to the left. Oops. Okay, there's the parent function. Now when I subtract 3, oh, it went to the right this time. Okay, let's see what happens with the parabola. Parent function in green. If I subtract 3, it also moves to the right 3. The same thing is going to happen to my absolute value function. And then my parent function, the parent linear function, subtract 3, it also moves to the right 3. So I can add to my notes. If you subtract a number inside of a grouping symbol, that's going to be a transformation to the right H units, however many units you have there. So example 1 in your notes is missing a picture. So it's asking, example 1A, how did the transformation of f to g in part A affect the intercept? Okay, so here's some information you don't know. F of x equals x squared. So that is my parent function that is a parabola that has a vertex of 0, 0. So I'm just going to sketch that in right here. G of x is x plus 1 squared. So we have added a number inside of a grouping symbol. So when you add a number inside of a grouping symbol, that's going to be a shift to the left 1 unit. So that means this vertex that was right here is now at 1. So everything got shifted. Oops, I just moved that to the left. I need to move it to the left, not the right. To the left 1, negative 1. Okay, and I will label the second graph g of x. Okay, so how did that affect the intercepts, and more specifically, how did that affect the x-intercepts? So the x-intercept shifted 1 to the left. And a similar question was asked in part B. All right, now let's talk about our second type of transformation. And we'll go back up here and we'll start to list it. So here were our first two. Our second two, and we're not going to do part B, so you can take your pen and you can mark this out because we're going to use all the space for notes. We're going to take f of x two different ways again, And we're going to see what happens if I add a value outside the grouping symbol or if I subtract a value outside the grouping symbol. So I'll go back to my parent function and I'll get all the parent functions back on here, and we're just going to see what happens when I add or subtract numbers outside the grouping symbols. And I'm going to not graph all of them at the same time. Let's just start with the absolute value. Okay, so here this blue graph is the graph of the absolute value function. If I add a number to the end, like maybe 4, oh, it shifted up 4. What if I add 1? Shifted up 1. Okay. What if I subtract 4? Shifted down 4. What if I subtract 2? Shifted down 2. So it looks like every time we add a number, the parent function will shift up. If you subtract a number, the parent function shifts down. And that shift applies to every single one of my parent functions. So even with the parabola here, I could add 3, and I can tell you before I even type this in, it's going to shift the parabola up 3 units. So we can add that to our notes. If I add k, we're going to shift our entire graph up k units. And if I subtract k, that's going to be a shift down k units. Next transformation. What happens if we take our function f of x and I make the entire thing opposite? So I put a negative in front of the entire equation. Also, if I take my function f of x and put a negative only with the x, what's that going to do to the parent function? All right, so let's grab our parent functions here again. Let me go back and make sure I've got only parent functions graphed. Okay, so let's start off with the square root function. Okay, so here's my parent function. What happens if I put a negative in front of the entire thing? It went upside down. What about with the parabola? Put a negative in front. It goes upside down. Will it happen with the 2? I bet it will. Upside down. And then the line, reflected, goes upside down. We call that going upside down a reflection across the x-axis because every single point that was above shifts down across the x-axis. So add that one to your notes. So if you put a negative in front of the entire function, that's going to reflect across the x-axis. And then what happens if you put the negative just beside the x and not the entire function? So let me pull back all our parent functions. Okay, and then let's start again with the square root function, function number 4. Here's the parent square root function. Instead of putting a negative in front of the entire function, I'm just going to put it with the x. Oh, it's flipped across the y-axis. Okay, now I'm going to move up to the linear function. If I put the negative with the x, it also reflects across the y-axis. Now, something interesting happens with the middle 2 functions. The absolute value function, if I put a negative inside the grouping symbols with the x, it stays the same, but it's really actually reflecting across the y. It just reflects it on top of itself. And the exact same thing happens with the parabola. You put a negative with the x inside the x squared, you won't see a change, but it's actually reflecting on top of itself because every point is getting reflected across the y-axis. So add that into your notes. If you put a negative with the x, that is going to be a reflection across the y-axis. So that's going to give us enough information to move on and do example 2. What is an equation for the reflected graph? And we can check by graphing. So we want to reflect the graph of f of x across the x-axis. And I can check by graphing on Desmo. So I don't really need this space right here unless you just want to copy into your notes what the graph looks like. But I'm going to take the graph of f of x and reflect it across the x-axis. So the way I do that, here's f of x. If I want to reflect it across the x-axis, I need to put a negative in front of the entire equation. So negative f of x, put a negative on the left. Whatever you do to the left side, you have to do to the right. Negative x squared minus 2. Then you can distribute that negative. So the reflected should be, just distribute this negative, negative x squared plus 2. All right, so here is, this is supposed to be the equation of the reflected graph. So let's see what happens when I actually graph that on Desmos. So the black graph here was the x squared minus 2. That's the problem that they gave me. Once I did all my mathematical calculations, look, it reflected across the x-axis. Nice. Okay, so then let's try the second one, part B. Now we need to reflect the graph across the y-axis. So that means I'm just going to put a negative inside the grouping symbol with x. So that means I'll be looking for f of negative x, where you put that negative with just the x. So I don't see any grouping symbols in my original problem, so I'm going to put them with the x, and the squared needs to be on the outside of it. So I'll have, let me zoom in so I have more space to write. Parentheses, negative x. I'm just going to have to write on the graph. That's just what we're going to do. Okay, so f of negative x equals parentheses negative x squared minus 2. And then I'm going to simplify this. So f of negative x equals, when you square a negative times a negative is a positive. So I'll have positive x squared minus 2. And so this is what it should look like when we reflect across the x-axis. Oh my goodness, it's the same as the original. Oh yeah, well do you guys remember that x squared minus 2, that's shifted down 2. If I reflect this across the y, it's just going to reflect on top of itself. So it's going to be the exact same function. All right, I've got one more transformation for you guys. And so we'll go back up and we're going to add that into our notes in this bottom part. All right, our next transformation deals with what happens when you multiply the function by an entire number. So going back to Desmos, pull that back up here. Okay, let's get rid of these, do my parent functions. Okay, make sure all these negatives are gone. Okay, so let's say I've got the square root of x and I want to multiply that whole thing by 2. Okay, maybe multiply it by 4. Okay, multiply it by 7. Okay, so what's happening is the y values are getting larger and larger. That's called a vertical stretch. Now, if that number in front is a fraction, it gets lower and lower, like 1/3, or maybe 2/3. Well, let's just go with 1/5. So those are called vertical compressions. So whenever you have a number being multiplied by your entire function, it's either a vertical stretch or a vertical compression. So kind of depends on what number that a is. So if a Get back to the notes. Okay, so it will be a vertical stretch if that A value is greater than 1. If it's not greater than 1, we'll call it a vertical compression. And I still need it to be positive because I want to keep it from reflecting, from doing that reflection across the x-axis. It will be a vertical compression if that A value is between 0 and 1. Now, when you put a number just with the x, we'll be dealing with a different kind of stretch and compression, and that deals with horizontal stretches and compressions. And so what that will look like when you do it in Desmos, instead of putting a number outside the front of the entire function, you'll put it inside with it, with the grouping symbols. So like inside the grouping symbol here, or inside a group, you can't see that graph, or inside a grouping symbol, like absolute, that's out front, inside right there. And then you can see that. Okay, so let's talk about how that's described. So f of bx. So it will be a horizontal compression if that b value is greater than 1. Because if you notice when I graphed over here, let's look back at x squared. Okay, so here's x squared, right? If I put a 2 there, horizontally, it gets compressed more together. Okay, now if that number is a fraction, we'll see a horizontal stretch, like it's stretched out more towards the horizontal axis. So we'll call that a horizontal stretch if that b value is between 0 and 1. Now on page 11 in your workbook, we start dealing with what do you do if you have multiple transformations that you have to deal with. So when you have multiple transformations, I'm running out of room here. When you have multiple transformations, the first thing you need to do is you need to identify the parent function. And I'm just going to abbreviate parent function, parent. And then number 2, you're going to apply the transformations. I'm just going to abbreviate transformations as trans. In the order of operations. And the order of operations is that same order of operations you guys have been working with your entire math career, PEMDAS. And I'll show you what I mean. So I think it makes sense if we skip and do example 5 first. So what transformations from the graph f of x is the parent function of absolute value of x are applied to the function g. Okay, so they've already identified the parent function here. That's the parent. So I want to know what the transformations were that happened. So what I do is I apply the order of operations to figure out what transformations happened and then in what order did those transformations happen. Okay, so I've got this, parentheses, exponents, multiplication and division, addition and subtraction left to right. All right, parentheses are grouping symbols. So on example A, I've got these grouping symbols right here. So I'm going to go in there. Within there, find x, and then what happened to x? Well, we added 3 inside the x. So when you add 3 inside of a grouping symbol. That's our very first transformation. If I look back up here, add a number inside a grouping symbol, you're going to be going left, however many that is. So right here, I added 3 inside the grouping symbol, so that means I'm going to be going left 3. Then the next thing that happened is that the entire function got multiplied by 1/2. Well, when you multiply the entire function by a number outside, that brings me to right here. I multiply the entire function by a number, and that was a 1/2. So it was a number between 0 and 1. We'll have a vertical compression. So we went left 3, and then we had a vertical compression of 1/2. Okay, part B had g of x equals the negative absolute value of x plus 2. Well, here are the grouping symbols. The next thing that happened was this negative. So then when you have a negative in front of your entire function, that is a reflection across the x-axis. So we'll say that there was a reflection across the x-axis. And then add 2 at the end, that is a shift up 2. Then at the bottom of page 11, we also have an example where we have absolute value of x is going to be translated to the right 3. So I'm going to take f of x to shift it to the right 3. I'm going to subtract 3 inside the grouping symbol. Then it says shift it 2 units down, so that means I subtract 2. And then vertically stretch by a factor of 4. So since that vertically stretched by a factor of 4 happens at the end, I put a 4 in front of the entire function. And the name of this new function, it tells me, is g, so I can say that this equals g of x. So you'll have several problems on your homework where you're asked to identify the transformations. So here's an example, example 4, absolute value of x minus 4. Well, since I'm subtracting 1 outside of the absolute value bars, that would be a shift down 1. And I know these say the graph, but I want you to also be able to identify the transformations. 5, the parent function would be x squared because there's a square here. But then there's also a minus 3 inside parentheses, so that tells me there's a shift to the right 3 units. Okay, so you guys will have some practice with this. If you have any questions, please type them in the discussion board. I'll be monitoring your progress as we go, but also you can reach out, you can schedule a help session, and I'll be more than happy to help you. Good luck and have a great day.